Hey class, Mr. Mohidian here with a couple quick examples of derivatives. So they're kind of just an assortment here of problems just to give you some more variety from what the practice assessment gave you. So let's dive right in. Here we have an exponential function. It's a number raised to a power. Contrast that with something like this, a variable raised to a number. So the first thing to recognize is the structure of this problem. The derivative of a problem like this, so the thing from your formula booklet will look something like this. The derivative of a number to a power is this exponential function times the ln of the base. However, this is not just x in this particular example. It has its own derivative. So hopefully you know what's coming. That's called the chain rule. So with this idea in mind, in our cloud there, y prime, or dy dx, whatever you want to call it, is going to be the same function, 6 3x squared times ln of 6. But since this thing has its own derivative, we're going to chain on 6x, because that's the derivative of 3x squared. So that's the chain right there. And that's really as simple as you can get it. Sometimes you might want to give its order a little more coherence, so I might call this 6 times ln of 6, rather 6x. Well, I can just put the x here. So that's these numbers right here in the variable, and then the exponential term at the end, but order here sort of whatever you like best. But that's good enough for now. You may remember properties of logs. We can actually bring this 6 back up here, but for now it's the derivative I'm more concerned about. So there's the chain rule within an exponential function. Over here we have some old trig friends, so we got to be careful here with the minus signs because we made it a little bit tricky, or triggy if you suppose. Sorry. So cosine, its own derivative is negative sine of x. Starts with a c, so that's one way to remember it's going to be negative. This negative out here is already there, so two negatives make a positive, in math at least. And the derivative of secant, straight from the definition, we proved this one in class, secant is secant tan x. So sine of x plus secant tan. There might be some way to simplify this using some trig identities. I'm not sure off the top of my head, but again, it's the derivative I'm more concerned about rather than the minutia of simplifying it. I have one more on the next page. So here we have, we have a sum here, so we're going to use at some point the basics of derivative of a sum, but more than that, we have some more work here before we get started. So before I do the calculus, notice this is still y equals. I'm going to rewrite that thing because it looks a little funky to me. So I'm going to rewrite that as negative x, so that's that negative right there, to the negative 1 power, because it's in the denominator, so I'm going to bring it out of there like so. I'm going to leave this thing untouched because I don't like to mix calculus and just non-pre-calculus stuff. It can be a dangerous mix. So now I'm ready for the derivative. Y prime is equal to, I'm going to use the power rule right here. So that's going to be a negative times a negative is a positive. X to the 1 less power, to 1 less than negative 1 is negative 2. So that's the power rule. Now here I've got to be careful. I have a composite function. So I'm going to use a bit of color here. Splash of the old, let's put some blue. So cosine of x. That's my inner function. It's living within ln of x, which is my outer function. So you know what the drill by now. That's the chain rule. So I'm going to take the derivative of the outer function, ln of x. So in your cloud here, we know that the derivative of ln of just x is just 1 over x. But this is not x, it's the blue thing, so we'll deal with that at the appropriate time. So 1 over x, ln of x is 1 over x, so ln of blue is 1 over blue, frankly. So 1 over cosine of x. But see, this is pretty bustling on its own, so we're going to chain on the after party here. So cosine becomes, its derivative is negative sine of x. So we can simplify this quite a bit. So x to the negative 2 is 1 over x squared, so that's simplifying y prime. If I simplify this business, I have, let's see, positive times negative is a negative. I have sine of x, and then on the bottom I have cosine of x. Well, this should be familiar. I can rewrite that even simpler, because I don't like fractions, even though I can't really do anything about this first one. I know that sine over cosine, well, that's just my old friend, tangent of x. So there is y prime. So there's a couple mixed bag of examples there, relatively straightforward derivatives in one sense, but a little more complicated than just the basic power rule. Hope this helps.